Welcome everyone! Today I'm continuing the Better Rocket series, where I build and fly all kinds of rockets in Juno. In this video I'll be designing a multi-stage suborbital rocket, so let's dive right in. In the last video I created a small single-stage solid-fueled rocket and flew it to about 11 kilometers, and that was pretty good, considering how simple the design was. But today I'm stepping it up with a two-stage rocket. It's a bit more complicated, but it'll fly much higher and faster than most single-stage rockets, making it a much more efficient choice in the long run. But what exactly is a stage? When you hear the word stage, you might think of a platform for play, something Shakespeare would have used. But in rocket science, a stage is a very different concept. It refers to a section of the rocket that contains its fuel tanks and rocket engines, all working together to propel the rocket higher. Once a stage burns through all its fuel, it separates from the rest of the rocket and falls back down to Earth. Some stages are even designed to be reused, which helps cut down on the cost of building new ones. But why do we need to drop stages? Why can't a rocket just carry all its fuel in one big tank and use a single engine? Here's the problem. Everything on a rocket has weight, including empty fuel tanks. So if the rocket burns through half its fuel, half the fuel tank is just dead weight, taking up space and dragging the rocket down. Extra weight means the rocket needs a bigger engine to overcome it. But here's the catch. A bigger engine needs more fuel, and more fuel means even more weight. You can see how this becomes a cycle, right? That's where multi-stage rockets come in. Instead of carrying all that extra weight, multi-stage rockets are designed with multiple stages stacked on top of one another. When one stage burns through its fuel, it separates and falls away, lightening the load so the rocket can keep going higher. This is crucial if we want to get into space. Another reason why we use stages is that in space, rocket engines don't need nearly as much thrust as they do on Earth. So engineers can design smaller, more efficient engines that use less fuel, but still allow the rocket to travel much further. So without further ado, here's the two-stage rocket. It has a powerful bottom stage with a separator, and an upper stage designed for thin atmosphere. Let's see how it flies. As this rocket boosts upwards, you might be wondering, why doesn't it just flip over or spin out of control? The answer lies in the fins on the rocket's body. These fins are there to keep the rocket stable during flight. If the rocket tilts in one direction, the air rushes against the fins and pushes it back to its original angle. This stability is thanks to the center of aerodynamics, which is the point where the rocket would naturally balance in the wind if it were held at that point. In this rocket, the center of aerodynamics is low, near the bottom. This means the top of the rocket always wants to point toward where the wind is coming from, in this case, up. This helps prevent the rocket from flipping and keeps it on a straight path. Now that we have a rocket that can fly high, let's work on the safe return of the equipment inside the rocket. This can be done in many ways, but the simplest way is to add something that can create lots of drag quickly. A parachute. Parachutes are basically just large pieces of cloth that make loads of drag and slow down the rocket. They can slow down a rocket at a moment's notice and only take up a small space, which is why they are used for loads of different rockets. And there's the main chute popping out right there. That was a relatively soft landing. Great. How does drag work though? Drag occurs when an object moves through the air and the air pushes back against it, slowing it down. Parachutes make use of drag by creating a large area that catches the air, generating lots of resistance, which creates an air cushion that helps slow its descent, which in turn can help stop things like this from happening. Alright guys, that's it for this video. I hope you enjoyed. Stick around because I'll be making some more cool stuff soon, like bigger rockets. And yeah, have a nice day.